In this video, we're going to explore measures of variation. A couple key terms to help you. We've talked about range before. Deviation, that's a new word. It's the difference between any entry and the mean of that data set. The sum of squares, we take each of those deviations, square them, and add them together. Next, the population variance and the sample variance, we take those sum of squares and we'd actually find the mean of them. Whereas standard deviations, then we take the square root of the variances, and it depends on whether we're dealing with a population or a sample. And there is a little bit of distinction between the two. The steps, though, if we had to find them manually, would be the same. It's just a little bit different formula in the end for variance and standard deviation, depending on population or sample. First thing we always want to do, though, is find the mean. And if we're doing population, find the population mean. We then would want to find the deviation of each entry from the mean. Next, we'd want to square each of those values. And to find the sum of the squares, we just add up all those deviations that were squared. To find the population variance, we take that and divide by the population size. And then to find the standard deviation, we take the square root. Now, if we're dealing with the sample, it's the same steps. So first thing, we find the sample mean. We find the sample deviation for each entry. We square each of those values. We add them all together. But when we want to find the variance, our denominator changes. Now we do the sample size minus 1. And for the standard deviation, we take the square root still, but again, our denominator is that n minus 1. So let's look at an example. We've got 8 plumbers that were sampled, and we want to find the variance and standard deviation. Now again, it's only 8 plumbers. They tell us it's a sample, so we're looking at the sample, standard deviation, and variance. So we want to look at that n minus 1 denominator. But we're going to go step by step using Excel to help us do this. So the first thing it told us, and we'll give you a couple things here that are going to be helpful. A column for our data, the deviation, the square deviation, our mean, sum of squares, and then we'll find the variance and standard deviation. Our first step, though, if you remember, was to find the mean. So I use the average, in this case A2 through A9. And I could just highlight them and do the same thing. The next step was to find each deviation. So I'm going to use the equal sign. I click first on the data point, minus the mean. And I'm going to use that mean over and over again, so I'm going to hit F4 to lock it into my formula. Now what I can do is just double click in the bottom right corner and all of those fill in. Now to square each of those values, I'm going to use equals. I click on the deviation, I put the caret key and the 2, and that's the squared symbol in Excel. And again, I can highlight, double click in the bottom right corner, and all my values come up. Now I want to add them together to get the sum of the squares. So I use the sum function, SUM, and then I can highlight all those values and hit enter. To find the variance, if you remember, I take the sum of squares and I'm going to divide by the sample size minus 1. In this case, 8 minus 1, which is 7. So sum of squares divided by 7. And last thing, if I want to find standard deviation, I just take the square root of the variance. So SQRT is the square root function. And there's my variance of 56.83 and my standard deviation of 7.54. And that's all doing it manually. Now, Excel will also do it by formulas. And the formulas are VAR for variance and STDEV for standard deviation. Important thing to pay attention to is that I put a dot P at the end for population and a dot S at the end for sample. That's very important. So if I looked at my 8 plumbers again, that's a sample, so I'd want to make sure I use these bottom 2 formulas, the dot S's. And if I do the dot S, and if I just put them straight in there, I'd have 8 entries, and I get the 56.828. And if I did standard deviation, again, I'd get 7.54. And you could go back and check that yourself as well. The last thing to talk about here is the idea of the empirical rule. The empirical rule requires that we're dealing with data that is symmetrical and bell-shaped. That's going to be very important. And if that's the case, What we know in general about our sample data is that about 68% of it will lie in the first standard deviation from the mean, 95% will fall within 2 standard deviations, and 99.7% of the data will fall within 3 standard deviations. Okay, that's why it's called the 68, 95, 99.7 rule. Let's look at a quick example of this. Say that we're dealing with those 8 plumbers. Since we just found the standard deviation, that's going to be helpful. And we want to know what percent make between $20,499 and $43,113. Now, if I want to know that, the first thing I want to do is fill in these values down here. I know that my sample mean was 35.575. That was one of the things I had to find. And I know that my sample standard deviation was 7.538. So I can first fill in the 35.575. And now I'm going to do plus and minus the 7.538 to get my first standard deviation. And I'll get 43.113 and 28.037. Now that's one value I want, so I'm going to mark that. That was one standard deviation above. But I didn't get the one standard deviation at the bottom, so I'm going to keep going with the lower ones. So I'm going to find this one right here by subtracting the 2 standard deviations. So it's 2 times the standard deviation, and that actually does give me the value I want. Now if I want to know the percent, I'm just going to add up all 3 that are within my bell curve, and that will tell me 81.5%. So I know that approximately 81.5% of plumbers should earn between $20,499 and $43,113.